Okay, here we are in chapter 4, 4.2, day 1, and we just keep building and building with these derivatives. So hopefully you have the chain rule down pat and the power rule down pat. Start off with a new rule. It's the derivative of a product. Derivative of a product. So what you've got is if you have a function that's the product of two other functions, product meaning multiplication. So if you have a g of x times an h of x, you're going to be able to recognize this as just any x term multiplied by another x term. You have not seen that in the past. If that's the case, then to do the derivative, what you need to do is you take the derivative of the first term, first function, multiply it by the second function, then you add to that the first function as it was originally times the derivative of the second function. Okay, I'm going to give you a little bit shorter notation for this, and this is the notation I want you to add to your blue sheet. So up at the top of your blue sheet, I don't have one here at home, you're going to see the product rule under the derivative. And the way we want to write it on there so it's short and sweet is if y is a function of u times v, u is an x function, v is an x function, they multiply together, then y prime equals u prime times v plus u times v prime. So add that to your blue sheet. You've got that on there. And we're just going to do examples practicing this today. And I'll try to point out why it's a product rule that you should be doing on each one. So here we want to find derivative, factor, and simplify. Find derivative, factor, and simplify. And this is usually where the challenge comes in, the algebra stuff. The calculus isn't so bad. Example 1. Got a function y that has the quantity 2x plus 5 raised to the 6th multiplied by the quantity 5x minus 2 raised to the 4th. Okay, the reason that this is a product rule is I've got an x quantity here multiplied by another x quantity. So my u is this whole thing, and my v is this whole thing. So I'm going to do product rule. Product rule says take the derivative of this first term. So pretend that's not even there. This we had in the last chapter. You've got an inside and an outside. So you're going to do your chain rule where the 6 comes down. The inside never changes. Raise it to the 1 last power. Multiplied by the derivative of the inside. The inside, derivative of 2x is 2. Derivative of 5 is 0, so I need the 2. So that's my u prime. I have to multiply that by the v. I'm going to keep this exactly as it is. The quantity 5x minus 2 to the 4th. Plus, now I keep the u like it was originally, the quantity 2x plus 5 to the 6th. Now I've got to do v prime. So forget that this is even here. I've got an inside, outside chain rule. Start here with the power. 4 comes down. Multiplied by the inside to the 1 less power. And then times the derivative of the inside. Derivative of 5x is 5. And then the derivative of a negative 2 is 0. Okay, calculus is done. Now, we can pull this 12 to the front here. Times 2x plus 5 to the 5th. And 5x minus 2 to the 4th. Plus, 20, we need a 20 out there. 20, 2x plus 5 to the 6, and then 5x minus 2 cubed. Okay. At this point, we're ready to factor. And the easiest way for me to teach factoring is for you to think of baskets. And baskets are separated by add signs here. So you've got two baskets. There's a basket here, and there's a basket here. And what factoring is you take out the most of the same thing from each basket. Okay? You want to take out the most of the same thing from each basket. So I think I've got a 12, and there's factors of 12 that we'll talk about. Think of this as 5 of these quantities. 5 of the 2x plus 5. Here I've got 4 of these 5x minus 2. Over in this basket, I've got 20. And then I've got 6 of these quantities of 2x plus 5. And I've got 3 of these 5x minus 2. So what we want to do is take out from both baskets the most amount that we can. So first of all, let's look at the 12 and the 20. Just think, what's the biggest factor that goes into both of them evenly? Well, the biggest one, you got a 2 that goes in. Is there anything bigger than a 2? A 4. 4 goes into both of them. And then I think that's it. 4 is the biggest number, so we're going to take out a 4. And then we'll write down what's left in the baskets later. Now I'll move into these things. How many of these 2x plus 5s can I take out? Well, here there's 5 of them. Here there's 6 of them. So I can remove 5 of them from each basket. Now I move on to these things. 5x minus 2. I've got 4 of them here and 3 of them here. So the most I can take out of both baskets is 3. I'm going to remove 5x minus 2 and remove 3 of those. That's what we're going to take out. Now you show what's left. And you do that with a set of brackets. So what's going to be left inside of this first basket after I take the 4 out? And when we take the 4 out, we're dividing it out. So we're just doing reverse distributive property. Use that a little bit. So the 4, the 12 taking out the 4, we're dividing it out, you get a 3. Now to this quantity. We've got 5 of these we took out. We only had 5 here, so there's none of those left, so I don't have to worry about that. Now these, I had 4 of these 5x minus 2s, but I took 3 of them out. So that leaves one group of the 5x minus 2. So that's what's left in this first basket. And if you think about it, if I distribute this back in here and multiply everything back out, I'm right back to what I had. So I'm just dividing out what I can. Now plus what's left in the second basket. Well, I had a 20, but I'm dividing out a 4, so that leaves a 5. When I multiply back in, I want to get that 20. I took out 5 of these 2x plus 5. I had 6 of them in this basket, so that left 1 of them in here. I had 3 of these 5x minus 2s, but I took out all 3 of them, so there's none of them left. So there's the factoring. And now the simplifying gets done in here with these baskets. We combine the baskets together. If you notice, the exponents on the parentheses are 1, which allows me to distribute here. So I'll have a 15x minus 6. Parentheses are gone. Distributing a positive 5. That'll be plus 10x plus 25. And then what happens is I can combine my x's and my constants. And I use these square brackets just to show that I'm at the basket part, what's left in the basket. These could easily be rounded ones without any issues. I'll go back to rounded if you like. I'll have 25x. And then here I'll have a plus 19. And then I still have all of this stuff left. 4, 2x plus 5 to the 5th, and then the 5x minus 2 cubed. And I could distribute the 4 into that one, but I'm not going to. Okay, That's your product rule in a nutshell. More algebra than calculus. One line of calculus, 6 lines of algebra. Try another. We've got y equals x cubed times sine of 2x. Okay, this, you have to pick up on, well, what should I be doing? What rule? X cubed times the sine of 2x. So you've got to u times the v. So that tells you product rule. So we're going to go right into derivative, follow the product rule. Okay, product rule says take the derivative of the first term, your u term. So that's just x cubed. That's a little power rule. 3 times x squared. Then you multiply by the v, the whole second term. And we add. Keep the first term the same, x cubed. Now we have to take the derivative of the second term. So the derivative of the second term is a trig function which has an outside and an inside. There's two parts to it, sine and then 2x. So the derivative of sine is cosine. We keep the angle the same. And then multiply by the derivative of the angle, which will be 2. Now to simplify, we've got 3x squared times 2x plus 2x cubed cosine 2x. If we do the factoring, we have two baskets. Baskets are separated by the big add sign. So inside, I've got a 3 and a 2. Nothing there. I've got an x squared, that's 2 x's. Here I've got an x cubed, that's 3 of them. So I can take out an x squared. And I've got a sine 2x and a cosine 2x. Can't do anything there. So 3 is left inside. The x squared is out. Sine 2x is still there. Plus, the 2 is still inside. I took out an x squared. That's going to leave me with an x. And the cosine 2x is still here. And none of this combines, so it's a sine x and a cosine 2x. So most of the time, the author does not factor the ones that have an x with a trig function. So usually only factor the ones with x, no trig functions in them. So if you've got one of each, an x term with a trig function, no factoring needed. So I just want to show you could still do that. Okay, can I get rid of it? I don't even know why I asked that. Nobody here to answer. Number 3. Y equals 5 sine squared 3x cosine to the 4th 2x. Now remember what it means to have that power next to the trig function. That means you have an inside squared, and here you've got an inside to the 4th. I'm going to take the time to rewrite that. 5 times sine of 3x squared, and then cosine of 2x 4th. So I see this as an x term times another x term. I don't care if it's to the power, but the x term times another x term tells me product rule. Okay, now the 5 multiplier. You have an option. You could put the 5 out in front of the product rule with parentheses around the whole thing, or you can include the 5 as part of